Hi everyone, so my name's Jessica Landgraf and I'm going to be walking us through a 30-minute mini lesson that utilizes the Geometry Sketchpad. So in my lesson, we'll start with a minds-on activity that kind of introduces the topic and gets the students thinking about what they will be investigating and exploring in this lesson. So after the minds-on activity, they will then get into groups and answer questions found on their handout by utilizing the Geometry Sketchpad. Okay, they'll be able to manipulate different lines and slopes to answer these questions. So before I begin explaining the activities, I wanted to mention that this would be for a grade 9 math class. It would relate specifically to the new curriculum. So the overall expectation is application of relations, which is C3, and the specific expectation is compare the shapes of graphs of linear and nonlinear relations to describe the rates of change, to make connections, to growing and shrinking patterns, and to make predictions. So this mini lesson will relate specifically to comparing linear relationships, linear relations, and investigating and describing the different rates of change or slopes. So the students will also make predictions throughout the activity as to what they think they're going to see when you manipulate the lines throughout the activities. The time I allotted to this mini lesson was 30 minutes. Okay, so the purpose of this lesson is to get students comfortable with the idea of slope. So it would act as an introductory activity or lesson before they even learn how to calculate slope. So the goal is for them to form a conceptual understanding of what slope is, and then to begin to investigate and explore how they might calculate it and put a value to that line. So the intent of this lesson is to get students to manipulate and explore the slopes of lines and to form their own ideas about the value we use to represent slope and how we might calculate it. So by using the Geometry Sketchpad, it allows students to visualize and manipulate how the slope changes depending on how you manipulate the lines. So it allows students to visualize the differences between slopes prior to understanding how slope is actually calculated. Okay, so using this software also allows us to manipulate real life examples like you can see on the screen here. So like mountains, roller coasters, hills, buildings, or buildings like the Eiffel Tower, they're able to visualize real life examples through this Geometry Sketchpad here. So this activity can also be used to relate the slope to triangles and their properties as well. So it can be extended to different ideas and what you're trying to teach, the concepts you're trying to get through to the students. So this activity will also give students the opportunity to make predictions about how the slope will change when we manipulate the lines. So overall, it allows them to manipulate the slope right on the computer and then figure out how they intersect instead of continuously drawing lines and erasing them. So the visual and exploration process is much more evident using this software than by using pencil and paper. Okay. So now that we know the curriculum content, the purpose, and the intent of this lesson, I will demonstrate what the lesson is on the Sketchpad here. So you can upload real life examples into the Sketchpad and manipulate it that way. So in the Minds-On activity, I've chosen 2 images from the internet that you can see here. One has a positive slope and one will have a negative slope. Once I assign the slope value to each of these images, I will then ask discussion questions and manipulate the images to change the slope. Okay, so we can manipulate the slope by moving it on the grid and comparing it to the other line segments. So questions I would ask include, what do you notice about these 2 images? I would ask them to compare and contrast them to see if they could get the vocabulary we are searching for, whether that's the steepness of the hills or the slope. Other questions I would ask include, do you think if someone was at the top of this hill skiing down it, do you think they would go faster depending on the steepness of this hill? How do you think we could calculate steepness? Which do you think would have a higher value, ones that are more steep or less? What if we flip the mountains going in the opposite direction? Do you think this would have the same slope? This Minds-On activity is designed to get students to question their understanding and to consider questions they may not have considered before. Okay, so I'm just going to demonstrate. So I just copied and pasted these images here from Google, and I just created a grid that they sit on. So what you do is you just go to the line segment here, and we're just going to create line segments that follow the steepness of these hills. Okay, so we have one there and one here. I put them both at the origin just so students can see and visually see the difference between the steepness of this line and the different slopes. Okay, so what you do, instead of doing that, you go here, delete that. You'd click these lines, and you go to measure slope, and slope will appear right in the corner over here. And we do the same thing for this line. And there we have two different slopes. So we have EF, and then we'll have EG as well. So they both start at the same point, but their slopes are different. Okay, so again, you could ask those questions based on this diagram that we see here before even drawing on the lines of the slopes. You can also manipulate these images as you can flip them like this. If we wanted to flip them going the other way, and show the different values that it represents so they're both facing the same way. You can shrink them and make them taller to change the slopes as well. So it's visually, we can see that this is a lot steeper than this would be, right? And then you could also move this line segment to change the slope as well. So if you notice in the corner here, the slope is changing depending on where I'm moving it. Okay, so that's just a visual component there for the Minds On activity that gets them thinking about what slope is. So if I just reset this here. Okay, and so next I would move on to the activity that I would have students complete in pairs. So the next activity is to get them to really investigate and explore this on their own without me leading the discussion. Here's the worksheet that they are following. So I created a worksheet right here that you can see. Okay, so if we go forward just to zoom it in. So they will be using the Geometry Sketchpad to complete this activity here. So it's what is slope, and then it goes the measurement of the blank of a line. So they'd have to get this answer throughout the Minds On activity when we were discussing what the slope is. Okay, so question 1 here is asking them to manipulate the mountain so that the slope is going to be equal to 1, and then they're going to fill in the table of values that they see here. So when they go back onto the sketchpad, so they're going to manipulate one of these lines. So we want it to be equal to 1, so they can manipulate the line. However they want to do it, they might manipulate the mountain and try and figure out where it would be to be a slope of 1. And then they kind of match up the mountain to equal that. And then they would go x is equal to 1, and the line crosses right there, so y would be equal to 1. So they would determine the x and y values for this line. They could also extend the line as well if they needed more values. Okay, and then they would, once they figured out how to do the table of values and they figured out how to put the slope in the right position, they would answer the question, how are they changing? So how are the x and y values increasing, decreasing? So they would notice that they all increase by a value of 1. Okay, they would do the same thing for question number 2, but then the slope is equal to 2. So then they would go back to their sketch pad, they would take the other mountain, they would have to flip this mountain to get a positive slope, and they're trying to get a slope of 2. So they would manipulate this so that they got a slope of 2, and then they would fill out their x and y values in order to complete that question. And then they're answering the same thing, how are they changing? So with a slope of 2, you'd have your rise over run, and they would figure that out using the table of values. So next I have compare the two mountains. So what do you notice between the two mountains? So they might talk about the steepness of the mountain. They might talk about how fast someone would ski down the hill. There's different thinking processes to answer this question that they might answer it. Now, the next question is asking them to plot a line that intersects point 0,1 and 5,6, and then draw a line segment between them. They would also plot a different line that intersects point 0,6 and 5,11. And then it would ask, what do you notice about the slopes of these two lines you created? So it's getting them to think about the lines that they've created here. Okay, now it says, now put both lines starting at the origin. What do you notice? So there will be a change in these two answers, and they will figure that out as they solve them. And then the last question here is name 3 places that you would notice a slope in real life. So this is to bring in that real life aspect of slope in the real world. And you'll see here, like there's mountains, there's hills, but there's also roller coasters, and like we've mentioned, buildings like the Eiffel Tower that you notice slope everywhere. So slope is in the real world, and we want them to notice that. And this is how we're going to be able to solve and put a value to what the steepness is. So essentially this activity gets them to think, gets them to make predictions about what slope is, how it changes, Is the higher value associated with a bigger slope, or is a higher value associated with a littler slope? Again, those discussion questions will really bring in the deeper conceptual understanding of what slope is. Okay, so that is my activity, okay, using the Geometry Sketchpad. And once again, just to reiterate, it is a lot easier to use it on the Geometry Sketchpad than pencil and paper, since students are able to visually see and manipulate the images and the lines and see the difference of the change in slope with what's created right here. And this is before they even know how to even determine what slope is or how to do rise over run. So this is just an introductory activity to get them familiar with what slope is. Okay, thank you.